without any further delay, let's start our topic, Kepler's law of planetary motion. Now, in this topic, I will tell you how Newton derivated his inverse square rule. Now, first understand about this Kepler's law of planetary motion. Centuries ago, a scientist named as Johannes Kepler gave us three laws of planetary motion. Now, what were they? Let's start. The first law says that the planet orbits around the sun in an eclipse, which is an orbit, and sun is located at one of the foci. Now, what is an eclipse? Now, I am going to tell you everything what you should know about an eclipse. An eclipse is a curve similar like a circle, and there are two foci in this. The sun is located at one of the foci and the earth rotates around this. This is what our first law of planetary motion states. Now in this eclipse, what is eclipse? First thing is that there are two foci which are actually the centers of this, and what is the mean distance? Here we will see a term named as mean distance, which we will understand in our third law of planetary motion. Now what the mean distance is? Now let this distance be d1 and this distance from here to here be d2. So our mean distance will be d1 plus d2 by 2. That is our mean distance. We will understand this in our third law of planetary motion. So this is what our first law of planetary motion states. Our first law of planetary motion says that our planets orbit around the sun in an elliptical orbit where sun is located at one of the foci. Now let us understand second law of planetary motion. The second law of planetary motion says that the line swept by the planet and the sun sweep equal amount of area in equal intervals of time. So what is this? Let us understand. Let this sun is there and this planet is there and this planet revolves till here. Now the area swept by this planet and this planet, let's say this planet is also after revolving around from here, the planet moved to here and then here. So the area swept by this planet to this planet, this planet to this planet, the area swept by these planets in time t will be equal to this area if this time taken by them is t. So this is what the second law of planetary motion states. Now comes our third law of planetary motion, which is the main one. From here, the third law, the gravitational law of Newton was derived. So our third law states that the cube of the mean distance of the planet and the sun is directly proportional to the square of the time period. What is this? Let's just see. The third law of Kepler states that the cube of this mean distance, this is what I have told you earlier, this is the mean distance, which is directly proportional to the time period taken by the object, the square of the time period. What is time period? The time taken by the planet to revolve one cycle around the sun is its time period. So this is what the Kepler's law of planetary motion states. Now I will tell you how did Newton derivated his gravitational law. So see, from first law we have seen that the Earth orbits around the sun in an elliptical orbit, but in an eclipse the derivations and mathematical equations are quite hard. So he assumed that the Earth orbits around the sun in a circular path. This will make our calculations easier. So let's say our Earth is here and the sun is here. The radius of this is r. Okay. So what we will see, we all know that from second law of motion, the force is directly proportional to m. So from here, first let me tell you what the gravitational law states. The gravitational law states that the gravitational force is directly proportional to g m1 m2 upon r square, where f is directly proportional to m1 and m2 and f is directly proportional to r square. Now I will tell you how Newton derived this 1 by r square. How Newton derived this? This rule is also known as inverse square rule. So for now, just understand that the centripetal acceleration formula is equal to v square by r. For now, just understand this. And let's say that the Earth has revolved one circle around the sun. So v is equal to distance upon time, where distance is the circumference of the circle, which is 2 pi r, and t is time period. So we will write it as t only. So what will happen? Force is directly proportional to A. We all know that from second law of motion. From here we can say that force is directly proportional to V square by R. V square by R. So what we will do now? This is V. So what we can conclude from here? V is directly proportional to R by T, since these both are constant. Now, and further we can say that V square is directly proportional to R square by T square. No doubt. Now, what we will see? What we will do? We know that from Kepler's law, third law of Kepler, R cube is directly proportional to T square. Okay. So what we will do? We will put R cube here instead of T square. So what will we will get? V square is directly proportional to R square by R cube. R cube. So this will cancel each other. So V square is directly proportional to 1 by R. 1 by R. Okay. Now we will put it here. What was this? F is directly proportional to V square by R. So instead of V square, we will put 1 by R. F is directly proportional to 1 by R, and this is R only. So from here we can say that F is directly proportional to 1 by R square. So this is how the universal law of gravitational was derived. Thank you.